Hello, this is Danica Dvorak, and my partner for this is Jordan Stevens. This is homework 19 for Engineering 460 Monte Carlo class. And the prompt for this is 8.2 in the appendix of our Simulation and Monte Carlo textbook. And the chapter title says Reliability Inference, but this prompt is really about jet engine failure. So it says that they're interested in determining survival probabilities for components. So in this case, for a jet engine, if we're given a data set that tells us when jet engine parts fail, can we figure out the probability of, like, at a certain time, the jet engine failing? So going into here, I'm going to have to kind of go through this fast because there's a lot of information, but we're using a Weibull random distribution with alpha and beta parameters. And they go through here and they're trying to find the min of that. And we're using alphas like with the conditional prior density of our beta. So it's building upon itself. So at some point it becomes an MC, not just a Monte Carlo simulation. So here is where kind of the actual problem starts in. It gives us 43 ages in hours when the jet engine fails. And so then we want to run this failure code to figure out the log likelihood, the probability of jet engine failure. And then, so once we have like that code to run, we set up the parameter values. So for alpha, we initialize that as the prior marginal, and the B initial is the mode of the prior given alpha. So here n is 43, and 43 is because that's the number of data points we were given, like that's the amount of hours that, or not hours, but the amount of data points that we have about jet engine failure. A is the starting alpha value for the Weibull distribution. That's the mode of the data. B is our beta, and that's determined by the alpha value with a gamma distribution. So 2500 is the middle between 2000 and 3000, which is where we're looking at in our data set. And then divided by the gamma, like this whole chunk of code. And then K is the number of iterations that we're going to do. And then Y is a vector of 3, and that is the test points that we want to try. So we want to figure out the probability for those points. And then, so they perform those 5,000 iterations, go through, and for their version, they pop out a bunch of graphs. We're going to switch over to MATLAB really quick. And so this is our function that, like the first whole chunk, you can see that the fail has those same parameters, our alpha, beta, x, and then the 3 y values and the number of iterations. And we go through here. I'll make this code come down so you can see all of it. And you can pause that at any time if you need to look at more of that code. But then in order to run the code, we have this. So our x here that goes really far over, this is that same data set with the 43 data points about the jet engine failure. Once again, n is the 43. It's the number of data points in x. We could have coded this to say like length of x. A is our alpha again, B is the beta, K is the amount of iterations, Y is this 0 matrix or array, and then the initial values for that we want to try and look at the probability for. So if I run this, and I already run it previously, that's why you're seeing it again, but our answer is about, what is that, 1,000? Yeah, like 1,000 times these numbers. You can see that these first 5 look about the same, and then that 6th one is a little bit different, but around 2.6 is where we're looking at. And it looks like I'm out of time, but you can see that this code works. You can read more about it in 8.1 through 8.3 of our simulation and Monte Carlo textbook. So hope that was useful. You can see that we were able to translate that over into MATLAB for you. And if you have any questions, you can leave it in the comments below. Thanks, guys.